So this evening, we are going to discuss one section from Smelter department, which is called converter section. And basically, we are going to learn on how the raw material, which is matte, is converted into molten blister copper. Okay, so before I start, my names again are Viyembo James. From converter section, we have several technologies or keywords that we use as we do or conduct our production. So we shall go through these words and try to understand them as much as possible. The first one, matte. Matte happens to be a raw material of a chemical compound that we use and treat so that we can produce the blister copper itself. So if we mention matte, basically we're talking about a chemical compound which is called copper 2 sulfide, iron sulfide. So to simplify it, what we are going to do is this. It's a compound which contains copper, contains iron, and it contains sulfur. If we say conversion of matte into blister copper, basically we are talking about removing this iron and this sulfur, and then what remains is copper. So the next term, which is quite common, it's called matte grade. So matte grade is basically the amount of copper in this ore compound, which is called matte. The next term is called slag. Slag happens to be an impurity or something dirty that we are supposed to remove from our compound, which is matte. This slag actually is formed as we remove iron. So the next one is called slag blowing. So the process of that supply of oxygen to the system is called blowing. But in this case, slag blowing means one thing, which is making of slag. We are using two stages, slag blowing and copper blowing. So we start with slag blowing, making slag, and then we finish with copper blowing, making copper. So slag blowing, we are removing iron. And copper blowing, we also remove the remaining sulfur. We have number 6, which is temperature. Temperature is quite common, isn't it? So if we talk about temperature, basically we are talking about the degree of coldness or hotness of a substance or a material. So how much hot or how much cold for that substance is called temperature. Pressure. Pressure have a lot of meaning. This one is scientific. It means force per unit area. This term is called flow rate. It's divided into two. So this flow, basically it means moving, and then there's also rate, which means time. For our production of copper, that oxygen coming to converter, it comes in a volume. So how much volume or how much package moving per hour is what we are calling flow rate. We have another one which is called magnetite. Magnetite is also a chemical compound actually. As we blow or add oxygen to the system, first we make slag, which is iron plus oxygen, okay? And then we make iron oxide, which is slag. Now if you continue blowing or adding oxygen to the system, if you're not controlling well, you will find that this iron oxide, and again you continue adding oxygen, you now form what we call magnetite. We need it in the production of copper, but not too much. If too much, problem. Again, if too small, problem. So we need to control. We have another one, which is very simple to understand, blister copper. So once we remove the iron, maybe just 1% remain. And also sulfur, maybe just 1% remain. Then what remains now is called blister copper, which can be in the ranges of 97 through to 99% of copper. We have another term here, which is feeding. So we get matte from another section, which is old electric furnace, or another section, which is reduction furnace, and we use a pot and then put inside converter. So that process of putting inside is called feeding. So now I come to this process. Skimming. Initially I said we are making slag in the process called slag blowing. How are we removing the slag, the impurity or the dirt? So the process of removing is called skimming. The next term called fluxing. If we say fluxing, we mean we are adding a material to the converter that is going to help us make slag. This flux is called silica. We are doing this process, fluxing, so that we can form slag. If we add silica stone, so slag will be on top like cooking oil, then copper below like water. So if you don't do this, separation difficult. And then we have this process which we call foaming. So basically foaming is a process upset that is caused as we are blowing the furnace. Not good, this one. If we make copper, which is blister copper, there's a process we call casting. For casting, we have mouths or something I can call like this box. Then copper we pour inside and that one come out. We give marketing. That process of pouring inside, we call it casting. Then rivets. So rivets, basically, you're talking about the cord materials that we use. Can be copper or some material which has a lot of copper that we use to control temperature. So number 17, punching. The converter has got hose which are 54. Those pipes for air to pass through well or smoothly needs to continue cleaning. So the process of cleaning those, it's called punching. Recovery. This one has too many meaning, but for our operation at converter, it means you are checking the amount of copper that you have produced. So this one, how do you check? First you check what we call inputs, and you also check the output. How many copper make? How many put inside? So output divide by input, it will show you how much copper you have made. The 19th word or term we are going to consider is called ladle. It's basically a big pot where we put raw material. Can be mat, can be slag. So we use it for transporting, moving from one position to another. There's a process we call banking. Banking basically it means it's a process of trapping slag. So how do we do banking? So after you make copper, you finish. You need to remove all the slag, all the impurities, all the dirt inside. We are now calling it banking. Another term which is very common is shutdown. If you're using equipment for too long, maybe finishes, or in other English we say wears out, it needs to repair or service or maintenance. So that shutdown, it means you stop production and then you do maintenance first. And that big word, convert, it simply means change. So we are just changing one compound into copper. So how to change, I'm going to explain. So now, how do we operate? As converter section, we have about 3 sections. So the first one comprises of the converters, the converter furnaces. And as we are blowing or as we are operating, mainly we'll find that 3 converters are working. Then 1 converter is on shutdown, repairs. So I mentioned when making copper, 3 processes usually are involved. There's slag making or slag blowing, there's copper making or copper blowing, and there's casting. So maybe 1 converter, slag blowing, another converter, copper blowing, another converter, casting or waiting for mat. Then we have what we call 50-ton overhead cranes. These are 4 as well. Then another small section we have for repairs and maintenance works. We call it a workshop. So these are converters. And then we have cranes on top. These are the ladles. So what are we making at converters? Basically we are making 2 things, but the important one is blister copper. So the blister copper is made in this range, 97 through to 99%, depending on the operation itself. And then after we make, we either cast or take it to anode section for anode production. And this is basically slag, but when mixed with silica, we don't say slag now, we say firelight. And then this is the impurity or the slag that we are removing from the converter. And then copper recovery, the copper, the 5% or the 2%, we don't throw it away. So we take it to ODF, electric furnace or reduction furnace, so that they can get that copper. And then come back as matte. Then we continue brewing. And then the byproducts. So the sulfur dioxide is basically the gas. And then we also have what we call flue dust. This is just a flow chart on how we work. Raw materials or matte is coming from 2 sections. One is old electric furnace and another one is reduction furnace. So as we blow and make slag, we take it back to reduction furnace or we take it back to ODF so that they can recover the copper. And then the copper that we make, 2 things as well. We take for casting so that we make blister copper, or we take it to anode. From anode, the copper slag, the impurity there, will come back to converter. And then the anode will be taken to casting and then we produce the anodes. Then there is what we call sulfur. So sulfur dioxide can pass through the WHB and ESP, then it goes to the dust can go to ISA or to acid plant, and the off gas will go to acid plant for acid plant protection. So this is just like a simple structure on how material moves. 3 important aspects of our operation that we look at. First one is planning. So some things we train them would be under control parameters like feed rate, mat level, matter grade, magnetite, some things I've mentioned. Then there's also organizing. You need to understand how many people are supposed to be in each position. So that falls under organizing. Manpower, people, and equipment in operations. Then the last one, which is important, inspection. So converters, basically we're talking about unit furnaces which are used to convert mat into molten blister copper. So this is our job. We have 2 stages, which we call slag blowing and copper blowing. Now from this, we are supposed to do the slag blowing. So this is what is happening in slag blowing. It's basically chemistry. Mat, it's copper 2 sulfide, iron sulfide. So our job to remove this one, and this one, so that we just remain with copper. In slag blowing, we are dealing with this one, iron sulfide. Then in copper blowing, we are dealing with this one. So 6 ladles we can blow depending on the matte grade. Because I mentioned earlier on to say, matte grade happens to be the amount of copper that we have in the whole compound, isn't it? So we have normal matte grade, then we have high matte grade, then we have low matte grade. What we call normal can be just in the ranges of 60 to 62%. So this will help me understand how I'm going to treat the furnace. You put mat, you start by putting oxygen, then you wait. The reactions will start inside. Usually in the ranges of 6 minutes to 15 minutes, depending on the matte grade. So as an operator, I need to go out and check the furnace. One thing I'm going to check will be the flame. So the flame will tell you if the temperature is high or low. In the ranges of 6 to 15 minutes, you also add silica. So this silica will now react with what we call iron sulfide to form firelight, which is supposed to be of this kind. So if we check on our reactions here, it's not very difficult. So this is the one I'm talking about, and it will produce this. And then the sulfur inside will equally react with oxygen to produce the gas, which is sulfur dioxide. And then too much blowing of iron oxide without the content of this, you will find that it will form what we call magnetite. This is how skimming is done. So you pour out. So for me, who is experienced, who knows the composition or how it looks, I'm able to tell, okay, here it's only slag coming out. If copper starts coming out, and then it will indicate now slag is finished, now copper coming out, stop, you continue blowing. For continue blowing, meaning you need to request, if you are completing the cycle with 9 cycles, it will be this format, or with 9 ladles, But if they say 10 ladles, you can just request for 2. Then after skimming, you request for another 2. Then you are done. So you need not more than 10 ladles, because our system can accommodate maximum, which you can't go beyond, which is 240. But this is too dangerous also. So the safe working load can be 200 or just 180. After 9 ladles or 10 ladles, there is what we call final skimming. So final skimming meaning last time you are going to remove slag. So now this one is very serious. This time around you need to make sure that all slag removed, because if some slag goes to copper blowing, that process I said forming can happen. If not much experience, there is also what we call a slag hook, like a small metal. You just dip inside, then remove, and then you are able to tell the level of slag inside and that of copper. So the level of slag is supposed to be in the ranges of 2 to 5 centimeters. If it's more than 5 centimeters, it means there's a lot of slag. So you continue skimming. That implies that you go to the next stage, which is copper blowing. Copper blowing may sound or seem to be very simple, but it's very difficult and needs full attention, full concentration, because if you make a mistake, you can lose a lot. From this compound I mentioned, we are now just remaining with copper 2 sulfide. This compound is called white metal in other terms. Copper blowing, no silica. We just continue oxygen so that we can remove the sulfur in it. So at this stage again, you may add some rivets so that you reduce the temperature. And then you continue blowing, which is adding of oxygen to the system. So now what happens is this one with oxygen will react fast with white metal again to produce now the direct copper. And that copper oxide will be removed at a later stage. In the process of making copper, so the temperature ranges which are acceptable can be of this range, but it needs to be monitored. If temperature is too much high, it also can damage the converter itself. Pressure, we have a pressure range which is acceptable. We can control pressure in this range, which is 70 kilopascals to 120 kilopascals. Flow rate, this is the acceptable range. The flow rate allowable is supposed to be 36,000 Newton meter cubed per hour. Then magnetite, I mentioned also in the mat that is coming, usually it's in the ranges of 11 through to 15% in mat. So magnetite again is very good. It can help us to make our furnace last longer. So there is also oxygen. The usage is very important. We get it from oxygen plant, and they allow us some percentages on how to use it. Then blowing time, acceptables for our furnace, and the type we are using, we just need about 260 minutes to finish, or 350 minutes. Then this, I talked about it, the capacities, because we just need 9 ladles or 10 ladles of mat inside so that we can blow our furnace. Casting process, after copper is okay, now we are casting into the mouths, which is ready to sell. If we take to anode, this is how they do the anode casting, and these are the anodes which are produced. And then the conclusion basically is talking about some things that we need to do if we are to improve productivity. So if we need to make sure that we want too much copper come out, then we are talking about proper use of rivets. Then equally, we are talking about skill. Skimming is important, but if you don't use skill, you lose too much copper, which is not okay. Then for skill, we equally need to do magnetite control. Then recycling scrap, this can be in form of rivets, that one which are coming from anode, which can be the anodes themselves or the launders and everything. Then training is also important all the time. We all the time need to train our operators so that they understand. Then sometimes we have new people, so equally new people need to be trained so that they understand the system. This copper alloy material, sometimes we remove from other companies, maybe KCM or Mopani. Sometimes they tell us this can be used at converters so that we can improve our recoveries or the output. So I'll end here. Any questions? Okay, so that's a very good question. I think if you check, myself, the time I joined the CCS, I think that was 2013. Up to now, cost management has improved. So one thing which has contributed is the recycling of materials. And then there are other measures that can be used, like for lime application or barium sulfate. Instead of using barium sulfate, which is expensive, we may go maybe to acid plant. They help us with some lime. So that one, we can mix with water and use it so that when we are cleaning our ladles, it's very easy. That equally can reduce on cost. So there are a lot of means that we are using as at now, because if we reduce on cost, it will mean more profit for the company, and obviously bonus or something for our people. So there are a lot of measures. There are too many. If I mention everything, I think time will be small. Yes. So any other question? Yes, madam.
Okay. Appreciate your time and your analysis.
It's talking about improving quality, improving recoveries, but equally I can use it to explain about quality. So the best measure, we work on quality, training all the time, and then checking on their operations. So many times, Mr. Wu and me, not many times at office. We have our operators, but many times checking them also. How are they operating? So it's a big task. And then the other thing is about safety also. It improves our quality. If our operators are safe, then even the mode of operation becomes safe and the quality is improved. Then the equipment itself, that's why I mentioned about inspection. You remember, if the equipment is not okay and you continue to blow, then the quality will be compromised. It will not be okay. So all the time we need to make sure the furnace, is it ready for blowing? If not, you first you call maintenance people. If it means repair, they repair, so that our quality is not compromised. So basically, that's how I can answer your question. Thank you so much for your time.